One of the things about today that's nice is, as compared to yesterday, we actually have an equal sign. And so when you are dealing with trig identities and equal signs, what ends up happening is you know where you're supposed to end up. And so when you know where you're supposed to end up, you know when you're done. Whereas like yesterday, it was kind of a challenge to know when you got to the end of simplifying things. So today I think we'll go a little bit easier than yesterday. And so what you try to do is you look at the left-hand side and you try to make it look like the right-hand side or vice versa. So here what I notice is that on the left-hand side, at the very top, I have a sine squared x minus 1. And in my trig stuff for the Pythagorean identities, I remember that there's a 1 and a sine squared kind of thing. In fact, if I were to look at this sine squared x plus cosine squared x equals 1 scenario, and I were to take and move the cosine squared to the right-hand side and the 1 to the left-hand side, what I would end up with is that the sine squared x minus 1 would equal negative cosine squared x. So by rearranging that most famous Pythagorean identity, then I could make the stuff look like my numerator. And what that means is I can then replace it with negative cosine squared x. So my next step is that I change that yellow highlight into what it is, which is the negative cosine squared x. And the bottom is still my sine squared x. So I took the yellow highlight, I found an identity for it from the Pythagorean identities, and then I replaced it. And now I notice I have cosine over sine, which we know is cotangent, but they're both squared. So I rewrite this as negative cotangent squared of x, and I have proved that what I started with is equal to the negative cotangent squared x. So when you make one of the sides look like the other side, you are done. When we've been talking about these things before, I talked about you look at something and something pops in your head right away. So I look at number 2, and the first thing that pops in my head right away is that I have 2 fractions. And whenever I see fractions, I always think about common denominator. So what I'm going to do is I'm going to attempt to get a common denominator. So I take my first fraction, and I multiply it by whatever I see on the bottom of the other fraction. That would be the secant of x plus 1. And then the second fraction, I'm going to ignore the stuff over here that says cotangent. I'll get to that later. I'm going to multiply by the other denominator, which was the secant of x minus 1. And the reason I can do this, of course, is because those things are actually ones, and I'm not changing what the fraction means. So now, as I look at my numerators, when I multiply 1 times this stuff on the top of the red, I just get the secant of x plus 1. 1 times secant, 1 times 1. But when I multiply the stuff on the right-hand side with the blue, notice how there's a negative sign in front of the 1? That means I have negative 1 times secant, so that's negative secant x. And I have negative 1 times negative 1, so that's positive 1. So all I did was distribute the 1s to their respective things. Down below, just like when I have something that says x plus 3 times x minus 3, and I FOIL this out and I get x squared minus 9, because the 3x's and the minus 3x's cancel out. These things on the bottom, the common denominator, are the same idea. I have a secant plus 1 times a secant minus 1. That will yield a secant squared x minus 1 when I FOIL it out. You can actually FOIL all of them out and find out that you have secant squared, a negative 1, a positive secant, a negative secant, but it works just like the difference of two squares with x's. It's just trigonometry instead. Now the cool thing here is that I notice that the secant and the negative secant cancel each other out, right? One's positive, one's negative. So then, what ends up happening is as I continue with this, on the top, I notice that I have a 2. And then I look to see, down below in this orange, if in my trig Pythagorean identities, do I have a secant squared minus 1 anywhere? So take your packets, look at the front page, and do you see anything anywhere that says secant squared minus 1?
Yeah.
What does it say?
Tan squared equals.
Tangent squared. So down below, if you look at the Pythagorean identities in your packet, highlighted here in yellow, you will see that the secant squared minus 1 is tangent squared. Yes?
Yes.
Okay. Now what I want to tell you is that you should also know that this is really the same as saying I'm multiplying it by 1 over the tangent squared. Because 2 times 1 is 2 on the numerator, and then the tangent squared is on the bottom. Do you guys see that? I just pulled the 2 out in the front. What is 1 over the tangent squared? That's correct, cotangent. So now I have 2 times the cotangent squared of x, because this stuff here, 1 over tangent squared, is the cotangent squared. And I have proven now that the stuff on the left is the same as the stuff that was on the right. And number 3, I guess what I notice is that I have 2 parentheses. And when I have 2 parentheses, that tells me that I'm probably going to end up either foiling or just multiplying. So rather than FOIL and create more things for myself, what I want to know is if you guys could take a look and see if this stuff in the green highlight here, is that a Pythagorean identity I can write down? It is? Okay. So cosecant squared x, and then times, then probably I should look and see if this other one, 1 minus sine squared,
Tan squared.
that one actually I know, that one is cosine squared x. These are both from my Pythagorean identities on the front of the packet. Now I notice that I have a cotangent squared over here. And I know that cotangent is cosine over sine. And I already see in blue my cosine stuff. So that means somehow I have to see sine stuff. And then I remember that this cosecant is really the same thing as saying 1 over sine. But since it's squared, I can't forget to write that down. And I still have my cosine squared x stuff. And then when I multiply those together, we know that even though they don't say it, that the cosine squared is over 1. And you multiply across the top and across the bottom, again remembering that that cosecant stuff was this 1 over sine squared. And I end up with the cosine squared of x over the sine squared of x, which I happen to know is cotangent squared of x, which then proves that it's equal to the right-hand side of that equation. In the last 3 problems, I've started on the left-hand side and then try to make it look like the right-hand side. So just to show you that you don't always have to do that, this time I'm going to start with the right-hand side. So I look at the right-hand side of number 4. And in the right-hand side of number 4, I notice that there's a fraction with only 1 thing on the top and 2 things on the bottom. And yesterday when we talked about our lesson, one of the things we talked about is there's kind of that secret trick. I think it was number 6 yesterday. And I told you multiply by the conjugate. So my strategy when I start working with the right-hand side is to multiply by the conjugate, which will be the secant, and now they switch to u, plus the tangent of u. It's exactly the same as what you see with the change of the sign. So now it's a plus sign instead of a minus sign inside the parentheses. And then when I do this, on the top, of course, I will have the secant of u plus the tangent of u, because it was 1 times all that stuff. And down below we see two things inside of parentheses, like a previous example, where we know that if we have like x plus 3 times x minus 3, it's the difference of 2 squares when we get done. So when I FOIL out these two parentheses, rather than do all that work, I can take the shortcut of saying the secant squared of u minus the tangent squared of u. And this allows me to skip some work that I don't necessarily want to take care of. And then seeing two different squared things in my denominator, I think about Pythagorean identities. So I go look at the front of my packet. And on the front of my packet, I'm pretty sure that this thing, this secant u, turns out to be something interesting. It's 1 plus tangent squared. So now I have the secant of u plus the tangent of u over, what did you say it was? 1 plus the tangent squared?
Yeah.
1 plus, thank you, 1 plus the tangent squared of u minus the tangent squared of u. So the stuff here in the green highlight in red turns into, down in purple, that same green highlight. And then lucky for us, we notice that in the denominator, the two tangent u things cancel out. And so we're really only dividing by 1. So I end up with the secant of u plus the tangent of u, which then shows that I arrived at the same thing that I started with on the left-hand side of the equation. Looking at number 5, and still kind of continuing with what we talked about, I'm gonna work again, I think, with yeah, let's work with the right side. Let's see what happens. So I notice on the right side that I have a part.
It's cosine.
No, because there's no squaring.
Oh, you thought. I did.
So I notice that if I break it apart, I will get 1 over the sine of theta. Again, now we have a different variable. Minus the sine of theta over the sine of theta. And if I do this, I then end up with the cosecant of theta minus 1.
I see where you're going with this. Oh, okay.
But on the left side, I notice that there's something squared.
Oh, yeah.
And there's also a 1 plus cosecant on the bottom. So what I'm going to do is I'm going to multiply by the conjugate.
Wow.
I know.
It's a 1.
So he's dramatic all the time. That's over math. True.
And I know that there's nothing on the bottom of the other fraction, so I'm just going to put it over 1. On the bottom of this fraction, I have 1 times cosecant theta plus 1. And oh look, the top thing is like the x plus 3, x minus 3, which gives me x squared minus 9. So this is going to be the difference of 2 squares as well. And I end up with cosecant squared of theta minus 1. And what I notice is my denominators are now the same. If I look at the denominator, this part is good in yellow, but the top part is not. So I look at this top part here, and I ask myself, hey, wait a minute, can I look at my Pythagorean identities and find something for that? And lo and behold, on that front page of my packet, I see that cosecant squared minus 1 is the same as cotangent squared. And now, when I rewrite it, I see that I have ended up with what I started with on the left-hand side. Again, that's because these two things are the same. So this last one that I'm going to do with you today, I'm also going to do from the right-hand side. It's number 6. And as I look at this thing, I guess what I'm going to do is I'm going to take this stuff and I'm going to rewrite it as 1 over the tangent of t. Now the fourth variable we've used for a angle measurement, x, u, theta, and now t, times 1 over the secant of t. And the reason this really makes me happy is I know that this 1 over the tangent of t is really the same thing as saying cotangent of t. And the stuff on the right-hand side, 1 over the secant of t, is really the same thing as saying cosine of t. Ta-da! Super fast.
She said she loved it.
So, first of all, the whoopsie, my bad, sorry. The 1 over secant was the cosine, and the 1 over the tangent was the cotangent.